Welcome back to Sandeep DH Education channel. So here today I will discuss a most important concept in quantum mechanics. So that is WKB approximation method and also variable method. So here in this video I will discuss only a WKB approximation method and the application of WKB. So it is also called as semi-classical theory. Okay. So in this approximation method we can solve some type of a quantum particle, solutions of some type of a quantum particles. So what are these quantum particles? The particle having size, the particle having microscopic size like electron, proton, atom. So these type of particles we can understand by using this quantum mechanics. And here when the potential function of the quantum particle is a slowly varying function, is a slowly varying function of position. So that means it depends on position. See, V of x, V is the potential energy of that particle, is a function of position. Then so we can solve this particle is by approximation method, and one of that approximation is WKB approximation. So today I will discuss only the application of this WKB. Okay. So let us see. For example, so let us consider two turning points, a bound states. Okay. So the particle is in somewhere in this particle in this bound state. Let us consider. So this is the position x is equal to A and this is the position x is equal to B. So this is the region 1, I am mentioned as the region 1, and let us consider this is region 2 and this is region 3. In the region 1, the potential energy of the particle is greater than E, and in region 2, the kinetic energy, a total energy of the particle is greater than potential energy, and in region 3, again the potential energy is greater than E. Okay. So if this is energy E, here V is greater than E and here also V is greater than E. So here E is greater than V. I am considering a particle is tapped like this. So this is the turning point. So this point is called turning points. In these turning points, see, so this is the turning points of the particle. So what is this turning points? Where the total energy E is also equal to potential energy. So that region is called turning points. The particle will change their energy in these particles. When the particle with high potential energy than the total energies comes in this region, when it enter into the region 3, its energy suddenly decreases, potential energy decreases and total energy increases. Again when the particle comes near to this end, turning point B, the potential energy is increasing and the total energy is decreasing. At this region V is equal to E. So V is equal to E region. So this is also E is equal to V. Okay. And the WKB approximation is valid only in region 1, region 2 and region 3. Okay, we can calculate the solution of a particle if the particle in this region, in all this region. So region 1. We can also get a solution. So if the particle in this region, we can also get a solution if the particle in this region. But when the particle enter into this part, so this is the turning point in this region, in these turning points. So for example, if we take, so this is the turning point, in this turning point while crossing this region to this region, what happens? Actually WKB does not explain what happens there. So we have a solution, we have a wave function psi 1 in region 1, we have a wave function psi 2 in region 2 and we have a wave function psi 3 in region 3, but we do not have solution in these turning points. So by using Airy function we can get the solution or connection. So we can also call it as connection formula for WKB approximation. Okay. So, this WKB approximation is valid only in region 1, region 2, region 3, not valid at turning points, and also it is valid only if the potential is slowly varying in the order of wavelength, lambda, de Broglie wavelength, that is, so delta lambda by lambda is greater than or equal to 2 pi. So, in this region only the WKB approximation is valid. So, this is the validity condition. Okay. And so, in the next video I will discuss the application of this WKB approximation method.